welcome, and what we're going to do right now, we're going to calculate a few limits analytically. So we're going to figure out how to do this. So for example, the first one is use algebraic methods to find these limits. So if you look at this function and you evaluate it at x equals 0, what you would have 2 times 0, 0 in the numerator, and then 0 squared minus 0, 0 in the denominator. So we have 0 over 0. That's the kind of expression we had in the first video of section 1.1. And I told you to remember this kind of situation because it's important, because, well, this is a little bit of a technique I like to remember. And it comes from my first days when I was teaching, and I made a huge mistake in front of the class because I said, well, we have 0 over 0, so we want to factor. And I wrote, I want to factor. I had just moved to the United States. I did not know what this stood for. So you remember now, 0 over 0, and you want to calculate the limit, that means you want to factor, not anything else you had associated to it before. So there you have it. So 0 over 0, we want to factor. So let's factor here as much as we can. So we get limit as x goes to 0 of, well, 2x is already in lower terms, so that's that. We leave it as it is. But then the bottom, the denominator, you can factor. You can factor an x out, so you factor that out. And you get x minus 1. Now, before you say, well, the x cancels, well, the x cancels when x is not equal to 0. When you have 0, that's what is causing you to have 0 over 0. 0 over 0 does not cancel. But remember our definition of limits. Our definition of limits said that we were looking at x's that were approaching 0 and not necessarily 0. They were not equal to 0. So here we have that x is not equal to 0 because we're looking at the limit, not at the value of the function at x equals 0, but the limit. So in this situation, yes, they do cancel. And then you get that this is equal to the limit as x goes to 0 of 2 over x minus 1. Now, if you were to evaluate this expression at x equals 0, you get 2 divided by negative 1. So you do not have anything fishy going on. And you can replace it, and you get that your limit is negative 2. And that is the way you calculate these limits algebraically. So if your factoring is not up to par, you'll have to practice and make sure you can factor things. For example, if you look at this expression, again, you plug in here 3 for x, and you get 3 minus 3, 0. And then 9 minus 3 squared, which is 9. So 9 minus 9 is 0. So you're getting 0 over 0 again. So what do? Well, you want to factor. And I will not write it again. But 0 over 0, you want to factor. So you factor, and you write this as 3 minus x. That's already in lower terms. Cannot factor that further. And the other one you write as is a difference of squares, so you write it as 3 minus x times 3 plus x. Okay, so in that case then, 3 minus x, when x is not equal to 3, this is an expression that is not equal to 0, so these two guys cancel. So now when we're talking about the limit, we can freely cancel, but that doesn't mean that in the function itself it cancels, but in the limit it does. So this becomes the limit as x goes to 3 of 1 over 3 plus x. And in that case, now if we plug in 3, there's nothing wrong happens. It's almost like as if you deactivated the bomb and it doesn't go off. It gives you a number. So there you have it. That's how you calculate that limit. So the limit of this function, 3 minus x over 9 minus x squared as x goes to 3 is 1/6. Let's do one more just to make sure you guys get it and you're good with it. What happens here? Well, let's plug in 3. Well, that's going to be 9 minus 3 is going to be 6 minus 6, 0. So that's good. And then 3 squared is 9, minus 9, 0. So we have 0 or 0, which now immediately you think we want to factor. And you write the limit as x goes to 3 and you factor your expression. Remember, this is a quadratic expression. You have to find two numbers such that multiplied they give you -6, and when you add them they give you -1. So -3 and +2 will do the trick, because when you multiply them it gives you -6. When you add them it gives you -1, and the bottom is a difference of squares, so you just do the difference first of the square roots and then the sum of them. And you see that when x is going to 3 but not equal to 3, these two expressions are not equal to 0 but equal, so you can cancel. And then again you now have steered out of trouble and you can plug in your values. And when you do that, you get 3 plus 2, which is 5, over 3 plus 3, which is 6. And that gives you 5, 6. And that's that. So I hope you guys, this is clear, this makes sense. And you can go ahead and practice those and make sure your factoring is up to par. Alright, thank you guys for watching.